Hello everyone, this is Dr. K. Amoda, Associate Professor, Department of Physics. Today I am going to talk about pumping methods. Let us first see about the conditions to achieve laser action. First condition is there must be an inverted population. What is that? Which means there will be a more number of atoms in the excited state than in the ground state. Our next condition is the excited state must be a metastable state. So let us go into detail about what is population inversion and metastable state. You take this two-level system, E1 and E2. Let N1 denotes the number of atoms in the ground state, N2 denotes the number of atoms in the excited state. Now you see this picture, number of atoms in the ground state is more than the number of atoms in the excited state. Whereas if you see this picture, number of atoms in the ground state is less compared to the number of atoms in the excited state. Now this first state is called as a general population state and the second state is called as a population inversion state. So we need to have this population inversion condition and this will stimulate more emission. So stimulated emission will to be effective for the light amplification. So this condition should be there. N2 should be greater than N1 and this condition is called as population inversion. Next I would like to talk about metastable state. Metastable state is the state where the excited atoms are made to remain for a longer time than in the normal excited state. You see this picture, three states are being shown: ground state, excited state, and the intermediate state is called as a metastable state. So whenever the atoms in the ground state get excited to the higher energy states, the lifetime of the charge carriers, you can see here it is 10 power minus 7 seconds, okay, will be less. So immediately it will undergo a transition. But if you have any intermediate state called metastable state, where these atoms are made to stay back for some time and the lifetime of the charge carriers is increased, say for example 10 power minus 3 seconds, then if the metastable state is a state where the lifetime of the charge carriers is made to be more than the normal excited state. So if the metastable state does not exist, then there is no population inversion, no stimulated emission and no laser operation. So this metastable state is a very important state in order to increase the lifetime of the charge carriers. Now let us see about pumping. What is pumping? Pumping is a condition. It is a process by which population inversion can be achieved. Rather, I can say it is artificial means of creating population inversion. There are several methods of pumping. They are optical pumping, electrical discharge method, inelastic atom-atom collision, direct conversion, and the chemical method. The pumping methods, first method what we are going to discuss is this optical pumping. Optical pumping, pumping is done by means of photons. In this type of pumping method, atoms are excited with the help of photons emitted by some external optical source. And mostly in the case of solid type of laser, you will have this kind of pumping. Example is ruby laser, neodymium, yttrium, aluminum garnet, NdR laser. So you can see this arrangement. So in the NdR solid laser, you will have a pumping source. So pumping source is must. So pumping source is a flash lamp. It will flash the light onto this laser medium and you could see that the atoms will gain energy and get excited. Now the pumping is achieved by the photons. You can see this picture. When a light is showered onto this atoms in the ground state, it gains energy and get excited to the higher energy states, thereby creating population inversion. Now you could see the number of atoms in the excited state is more than the number of atoms in the ground state. Population inversion is being achieved. Next pumping method is electrical discharge method, that is excitation by electrons. Here, the electrons are accelerated by very high velocities due to a strong electric field, and these accelerated electrons in this discharge tube will collide with the gas atoms and the gas atoms are raised to the excited state. This type of excitation is called as the electrical discharge method. Most of the gaseous laser will work under this pumping method. Say for example, argon laser, carbon dioxide laser, etc. In this method, the electrons are produced in an electrical discharge tube. Then the electrons are accelerated to very high velocity by using the strong electric field. These highly energetic electrons collide with the gas atoms and transfers this energy to these gas atoms. It is represented by the equation. Say for example, A is the gas atoms and E is the electrons. E star denotes the high energetic electrons. So when electrons collide with the A gas atoms, it transfers its energy and A becomes highly energetic, and it will be in the excited state, and E loses its energy, and this kind of electron excitation process continues. This method of pumping, which is used in this argon and carbon dioxide laser. Next, third method is called as direct conversion method. Most of this semiconductor diode laser will be having such kind of pumping. Here, the combinations of electrons and holes takes place in the semiconductor due to the supply of electrical energy. Hence, the electrical energy is directly converted to a light energy. That is, the electrical energy supplied will be directly converted to a light energy. This method is called as direct conversion. For example, gallium arsenide semiconductor laser will have such kind of pumping method. The fourth method is called as inelastic as atom-atom collision. So the collision is going to be inelastic in nature, and the collision is taking place between the mixture of gas atoms. Okay, let us take two gases, say A and B. This is possible only if these two gas atoms are having a same or nearly equal excited state. The first step is the same as for electrical discharge method, where the accelerated electrons, highly energetic electrons moving with a velocity, high velocity, collide with the gas atom A and bring the gas atom A to the excited state. Then the excited gas atom A collide with another gas atoms and transfers its energy to the gas atom B, and it undergoes de-excitation and the process continues. That is, you could see that E star plus A gives A star plus E. A star plus E, that is, E is the charge of electron, which is going to be very less. Then this A star plus B will give rise to B star plus A, and this process continues. It takes place in the case of carbon dioxide laser. You can see this picture, you will understand. In the case of carbon dioxide laser, a mixture of gases are being used. Carbon dioxide, nitrogen, and helium. And you have this inelastic atom-atom collisions taking place in a active medium. So for excitation, you will have a DC excitation where the electrons are generated and they gets accelerated. That is, you can see here. In the first step, during the electrical discharge, atoms of A are excited to a higher energy state A star due to the collision with the electrons. Then these A star atoms at higher energy levels collide with the B gas atoms in the lower state due to an inelastic atom-atom collision of A. The atoms gains energy and hence they are excited to the higher energy state B star. Hence the atom A loses energy and returns to the lower state. That is, A gas atoms collide with the highly energetic electrons, give rise to A star higher energy state gas atoms plus less energy electrons. And next step, this high energy gas atoms collide with another gas atom B and bring this gas atom B to the higher energy state, and A loses its energy and ready to collide with the electrons, and the process continues. You can see this energy transfer from one gas atom to another gas atom by these energy level diagrams of this carbon dioxide and nitrogen. So in the CO2 laser, a mixture of gases are being used, and among which this carbon dioxide and nitrogen plays a vital role. First step, the nitrogen colliding with the highly energetic electrons and get excited to the higher energy state. And since this nitrogen is having the nearly equal excited state as that of carbon dioxide, by means of inelastic atom-atom collision, nitrogen collides with the carbon dioxide, bring the carbon dioxide to the higher energy states. And once the population inversion being achieved in this energy level, then the transition takes place between the metastable state to the lower energy states, and the where laser will be emitted. So here in this kind of carbon dioxide laser, electrical discharge followed by inelastic atom-atom collision takes place. The last method is the chemical reaction method. Due to chemical reactions, the atoms in the ground state will be moved to the excited state. For example, dye laser, chemical lasers, all this are working under this kind of pumping method. Thank you for watching.